G'day guys, today I'm going to show you how to make a deck randomly shuffled. There's many different ways of doing this, but I'm going to show you a long but intuitive way of doing it. So, what we're going to do, we're going to see that 4 of hearts is our bottom card right now. Okay, we're going to take the top card, which is our 10 of hearts, and we're going to randomly poke it anywhere in the deck. So, put it in there. Okay, so we've randomly poked it in there. Now, we're going to continue doing this, taking the top card and randomly putting it in the deck. Okay, my question to you is how many pokes do you think it's going to take before we get a top card going below our 4 of hearts? Well, if there's 52 different places that it can go, and there's one place for it to go underneath the 4 of hearts, it's going to be a 1 in 52 chance of getting it underneath the 4 of hearts. Now that should take us approximately 52 pokes then, okay? So it takes us approximately 52 pokes to get it underneath that 4 of hearts there, okay? Now, we take the next card, we randomly put it in somewhere, randomly poke it in. Now, how many pokes is it going to take for it to get underneath that 4 of hearts again? Well, there's 2 places it can go underneath here, underneath the 4 of hearts, and there's still 52 places it can go overall. So there's 2 out of 52 places. So 2 out of 52 chance of it going below of the 4 of hearts, below the 4 of hearts. That means it's going to take us approximately 52 divided by 2, which is 26 pokes before we get it either there or there. Okay, so there's an equal chance of it going in either of these places. So it's randomly being assorted underneath the 4 of hearts. Now we do this again, poke, poke, poke. Now we see if it can go below the 10 of spades, it can go below the 6 of diamonds, or it can go below the 4 of hearts. Okay? So, in between those cards there and here. Okay, so there's 3 different places that this card can go for it to be below the 4 of hearts. Okay? So there's a 3 out of 52 chance of it going below the 4 of hearts. So it'll take us approximately 52 divided by 3 pokes before we get it below the 4 of hearts. And the cards, there's still an equal chance of it going in either of these places. Equal chance, okay? Sweet. So if we continue doing this, obviously we'd get more cards underneath the 4 of hearts. So if we put a card and it goes above the 4 of hearts, then our 4 of hearts does not move up or down. But if we put one and it randomly goes underneath the 4 of hearts, then it's going to slowly rise up. So it's going to increase its height up in the deck. So eventually we're going to get this 4 of hearts at the top of the deck, right? And all the cards below it should be randomly assorted. There should be an equal chance of each one going in the place it went. Okay? So 4 of hearts are now on top. Okay, it was on the bottom. Now, the chances of this 4 of hearts going below the 4 of hearts, well, there's a 100% chance it's going to go below itself, okay? And then once we do that, we'll see that we have a randomly assorted deck. Now, the math of that is, I'll show you. Okay, so now we'll go over the math of it. So we knew, as I said earlier, that the probability of putting our top card underneath our bottom card when we're doing the first poke was 1 over 52. Okay, so that was our probability of it going below our original bottom card. So knowing this, it would take us approximately 52 pokes for us to get the card underneath the bottom card. If we're doing it randomly. So 52, we'll go 52 over 1. That'll help us understand later. Now, that was our first probability. Now, the probability of doing it with the second card, so we got our top card below our original bottom card. And so the probability of doing it with the second card is going to be 2 over 52, because there's 2 places it can go in the deck to make it go below our original bottom card. Okay? And knowing this, that means we have, it will take us 52 over 2 pokes to get it below our original bottom card. That is equal to 26. I'm just going to leave it as 52 over 2. And then, as you can see, I'll do one more before we jump to any conclusions. I'll just do one more. P3 is going to equal 3 over 52 because there's 3 places for the card to go. Okay? That means the number of pokes is going to equal to 52 over 3. Okay, now, as you can see, our number of pokes that it takes to randomize the deck, we have 1, it's 52 divided by 1, 52 divided by 2, 52 divided by 3. We can see a bit of a pattern. So, if we put this into a bit of a formula, we know that our n, which is our number, we're going to call our n our number of pokes, is equal to 52 divided by, we'll call it little n, which is what card we're on. So when we're on our first card going underneath, it was 52 over 1. Our second card was 52 over 2, 52 over 3, and so on. And we want to sum this between, we want it between 1 and 52. Okay, so that's basically going 52 over 1 plus, so that, plus 52 over 3, 52 over 2 plus 52 over 3, and we go da-da-da-da-da until we're at 52 over 52. And that's when we're on our last card. And like I said earlier, there's a 100% chance that this card will go beneath itself because there's nowhere else for it to go. Looking at this now, we can change this to a bit of a, we can change this to an integral. So an integral is going to sum these for us. 52, 1, and we have 52 over n, and then that's all within the dn. Okay, now to simplify this a bit more, we go 52, take 52 out of our integral. There we go. And it's going to be 1 over n inside here. And that's dn, and then our limit is still 52 over 1. 52 over 1. So it's getting a bit messy there. 52. Okay, so if we integrate this now, we're going to get 52 times, well, the integration of 1 over n is going to give us ln, sorry. And that's between 52 and 0. 52, and 1, sorry, 52 and 1. Okay, now, if we carry this on, we're going to go 52 times ln of 52. And then that's going to be, we're going to subtract 52 times ln of 1. But if you put that into your calculator, ln of 1, if you put that into a calculator, you'll see that ln of 1 is actually equal to 0. So we actually just got 52 times ln of 52, and that's going to be our number of pokes. We can put that into our calculator, 52 times ln of 52, and you'll get approximately 205. Go like that. 205 pokes. Okay, so as you can see, this isn't a very efficient way of shuffling. Well, it's an efficient way, but it's not. It's going to take a long time. It will give you a completely random shuffle deck, but it's going to take you 205 pokes.